Thanks so much, Kim. I really appreciate that. My clicker.
Your clicker.
All right, I think we're going to do that. So really great to see everyone. Glad to have you here, and grateful to chat with you. And making sure this is all good. I'm kind of used to talking with these kinds of things, so hopefully that works for you. Little bit about me, like Kim was saying, born and raised in Arizona. So Phoenix, I was born in Phoenix, and I grew up in Scottsdale. So, okay, let's go back to the 1970s when I was growing up. And so right in through there, my very first memory is of a flooding event. So my family was putting sandbags around our house. So this is in Scottsdale over by Indian Bend Wash. This is before there was a wave for flood control protection along the Scottsdale area, along the Indian Bend Wash. And so there was water coming in. And this is my first memory. So, you know, that's something. When you talk to most meteorologists, most climatologists, there's something that happened in our formative years that it was like, and it stuck with us. And absolutely, it was water for me. And so trying to understand it, you know, there's too much water, not enough water. So I ended up getting 3 degrees in that, right? Because that's what you do when you want to learn more and more and more and you want to understand. And, you know, that first event, once I understood the meteorology, and I may give a little bit of meteorology for you guys. Are you okay with that? You're okay. We're all gonna learn all these things. But you know, once I learned all of that, I went back to the 1970s and why there was a flooding event. And that flooding event was significant for the state. It happened in September, Labor Day of 1970. It was a tropical system, a tropical cyclone, and its name was Norma. And it came in, and it was the wettest event that we've had for a 24-hour period of precipitation ever for the state. So we had over 11 inches of precipitation in one location in 24 hours. Now, when you compare that, I mean, statewide, what's our annual precipitation statewide? 12 inches, right? So over 11 inches in 24 hours was significant. And there were, sadly, 24 fatalities from that event. So it was the deadliest flooding event that we've had in the state. So I'm very cognizant. Those are the kinds of things that I pay attention to. Those kinds of extreme events like too much water, flood, not enough water, drought. And so we'll be talking about those kinds of things. This is my first time down here. I usually go to Bisbee, Tucson. I love talking across the state. This is the first time I've been down here. Now, some of you who are birders, I'm seeing the birders, and I know this is a birder location because my father-in-law, Charles Saffell, maybe some of you know him. He would come down here all the time. He was a renowned birder for the state. So I am not. Don't ask me anything about birds, but you can ask me about clouds, right? You can ask me about that kind of stuff. We're good there. So we're going to kind of talk about these kinds of things. Let's see if I've got the right clicker. And we do have. So again, very, very happy, grateful to be here. Hopefully there will be time for some questions because the stuff that I bring forward, and I'll probably bring up some numbers because, you know, as an academic, that's what we do. We keep track of things. And as a climatologist, that's what we do, keeping track of things. And so just to kind of, you know, understand where we're at, where we've been, and it's harder to tell us where we're going to go, but I'll kind of give you some of that as well. But when we're talking about drought in particular, that's a challenging kind of situation because I've set for the state of Arizona, and sorry folks, you'll probably hear me talk a lot about Arizona as the state climatologist, but I did tell some of you folks that Dave Dubois is the state climatologist for New Mexico. Great guy. He's over in Las Cruces, and he goes all across the state as well. And so I would invite you to reach out and chat, and you'll see some of the The maps that I bring forward are going to include New Mexico. So it's not just going to be the Arizona maps, but the stats that I talk about will probably be Arizona. So disclaimer right in through there. But really glad to have you here and talk about these kinds of things, like how, as the state of Arizona, how do we assess drought, what's going on with that, and then what I can do. And what our office does try and do is we keep track of those numbers, right? I mean, when you look at all of the weather stations that are out there, how many numbers are we actually talking about? Lots and lots of numbers. So, and you absolutely can go look at all of these numbers, but making sense of those numbers, that's really where that statistical side of climatology comes into play. And hopefully that's what I can bring, is that context. Like, okay, I remember this time, that time, right, but where does it stand with all of the other stuff that we're dealing with? So hopefully that's what I can bring forward. And we'll talk a little bit about what we're expecting this winter. What do you think we're expecting this winter? Okay, we'll chat about that too. All right, so here we go. Now, this is what you're gonna see when you're looking at most of my slides. Probably most of my slides, you're gonna see maps like this. All three of my degrees, when we're teaching people in Arizona meteorology and you're getting a degree in meteorology, you get a degree in physical geography, right? So all three of my degrees are in physical geography. And what geography does is it finds patterns across space. And so when we're looking at meteorology, where's it gonna rain? What's going on in the atmosphere? Where's that moisture in the atmosphere? Where's it gonna drop? What kind of conditions are we dealing with? So we're gonna talk about soil conditions, and then where's that water gonna go? So those kinds of things are very geographic. And what we're looking at here with these kinds of maps, they're statistical, so climatological kinds of things. The fancy way that we look at these kinds of things, we'll add everything together. So we'll look at January, February, March, April, May, we'll add all of those numbers together, and then we'll compare it to kind of the long-term average, or what we call a 30-year normal, which is we'll add 30 years together to try and understand what's going on. So that way, that tells us, like, is this above or is it below? So you're gonna see lots of maps like that, but that's how you can interpret it, like, where do we stand right now? And so now what you're looking at is looking at the western United States. So this map runs January to June. I'm gonna show you some things for individual months. So we'll take a look at that. And I'll talk about the Southwest because I did want to include New Mexico in our discussion, right? So I pulled out some of the Southwest data. And so what that means, it's the 4 states, right? So we have Colorado, Utah, New Mexico, and Arizona. So we're adding all of those numbers together. The thing is, we're seeing those trends in all of the individual states. We're seeing those individual trends in a lot of the counties. And so that's kind of where you're gonna see numbers, and it's gonna be kind of those larger kinds of numbers for those larger kind of places, I mean. But essentially, we're all in the same boat. And so that's what I wanted to make sure you understand when I'm showing you all this stuff. So you're looking over there, and I've got the individual months. January wasn't so bad. I mean, so we look at this, and you'll see the colors, and the blue means it was colder than normal in January, not just for Arizona, but the Southwest. And with January, it was great. We ended up having some cold systems in Arizona, not so bad, and that's what we kind of expect in January, right? Then we go into February. February, not so good. So it ended up, here's a term for you. When we talk about what's going on in the atmosphere, we talk about ridging. So we talk about ridges of high pressure. So when you see on those weather maps, you have those H's and the L's. If you have more of those H's over you, that typically means you're gonna be hot and dry. You're not gonna get storms, and you tend to be warmer. So we did have a lot of that happening in February. So you can see in the Southwest, it ended up being the 8th driest for the Southwest. It ended up being the 2nd hottest for Arizona. So we keep track of these numbers too, right? Then March was okay. not so bad. April, not so bad. And then May, not so bad. When we're looking at those temperatures, it was still warmer than what we wanted it to be, but not as bad. So if we look at January through May, and we add all those together, and it says down there it was the 17th hottest, what that means is we've been keeping track of these numbers since the 1795. So you're going back 125 years easily and trying to find out where these things stand, like what's been going on. So that's what you're seeing right in through there. So then we'll take a look at the precipitation. A lot of browns on these maps. And this is telling us, like, has it been wetter than normal? And so again, we're still looking at the Southwest. I pulled in January to June, but I wanted to pull in January, February, March, April, May. January was dry. It was dry everywhere. It was dry across the state of Arizona. It was dry everywhere. You can see it was dry in the Southwest. And when we're looking at those kinds of things, if we were to add in December, we were coming from a really dry December. Everybody remember that? Not so good. Really dry December, a really dry January. Those two together, the driest December to January on record for the state of Arizona. So it was darn dry when we're looking at what should be one of our wetter times of the year. And then you're seeing with that February, that ridging, we didn't have many storms. We want February to be wet as well. March, we had a couple of systems. In Arizona, we ended up getting some snow. So you can see it's kind of like for the Southwest, it's like, hey, everything's fine. April, we ended up getting some snow in Arizona as well. But by then, seriously, by then, when we're hitting March and April, we're starting to dry out, right? So when we're looking at our winter precipitation, it's usually December, January, February, March. March, we start to dry out. April, we start to dry out. And then we hit May, and we're starting to move into the three driest months of the year for the state, which is May, June, April, May, and June, when we're looking at that. So here we hit May, and you can see that we're drying out. And for the Southwest, we ended up with the 16th driest, looking at January through May. And if we're looking at the state, not as good either. And so when we're looking at how dry things have been, it's been dry. Does that give you some context? That makes sense? All right, okay, as long as everything's making sense, that's what we want. Okay, let's look at some more of those, I call them the angry colors, because we're looking at June, July, August. So here's a heads up. When we're meteorologists, we keep track of those numbers, right? And it's easier to keep track of a summer if we start it at June 1st and we end it on August 31st. So we're looking at meteorological summer numbers, which kind of keep us in track. I mean, it's close. We've got fall coming up on Monday. It's close enough. And so June, July, August, that's what you're looking at here, the Southwest. You can see very warm. And, looking at these kinds of numbers, it was in Arizona, June was the 17th warmest. July was the 24th warmest. And then we just ended August, those numbers, second warmest. And so on record, out of 125 years. So it was exceptionally warm when we're looking at these numbers. And one of the things that we pay attention to are, do you guys get to Phoenix too often? Right, I know. So we look at Maricopa County because it's the hottest, most populous county for the state of Arizona. And it's the hottest, most populous county for the United States as well. So we pay attention to a lot of those numbers, and we count how many times we've hit 110 degrees, for example, for the summer, for that whole year. We also count how many times at night we haven't cooled off below 90 degrees at night. And so This summer was not as hot as the last couple of summers have been. So I'll take it, but we do see things are fairly warm. And then looking at the precipitation, so this is summer precipitation, June, July, August. June was the 20th wettest June for Arizona. Here's the thing, January, February, March, April, May and June were the wettest months for Arizona. May and June are when we start drying out, and June is the driest month statistically. These are statistical things, and June will be the driest. And to get precipitation, and it's like, oh, June was so wet, but compared to being a very dry month, you still don't get a lot. And so June 20th wettest, great for Arizona, but still not a lot of looking at those numbers of precipitation. July was the 14th driest. August was the 16th driest. The summer was the 12th driest. Those are Arizona stats. You can see what was going on with the Southwest. You can see here, looking at where that precipitation landed. It was on the eastern side of New Mexico and into Colorado along the eastern side. And that really plays a role as to what happened with the monsoon season and how that played a role on the east side of New Mexico and Colorado, and not us as much. You can see down here, Yuma. So Yuma County right in through there is like, hey, I'm not doing so bad. And that's the same kind of situation when we're looking at stats. Yuma is going to be very, very dry in the summer regardless. It doesn't get a lot of precipitation during the monsoon season. And the fact that it gets an inch of precipitation in the summer, it's all of a sudden going to turn into those green colors. And that's what you'll see. You'll see these kinds of numbers. It's still not an absolute number of a lot of precipitation. So how'd the monsoon go for everybody? I know. Believe me, I was watching. And El Paso, the National Weather Service, put out a flooding polygon over here. So there was dumping into the ground. One of the things, though, that we have to pay attention to when we have really dry lands and we're dumping a lot of rain in a short period of time, we all deal with that same kind of situation where we can get that flash flooding. And so that water runs off instead of infiltrating, instead of going in. So those are some of the situations that we have to pay attention to and we have to deal with. But looking here at the monsoon season, I think these numbers, these are going to August 8th. And we've done a little bit better. We actually had some precipitation, some moisture that was coming in from another tropical system, Mario. And so California did pretty good, but it's the same kind of thing. If you get too much rain in a short period of time, you're going to have that flash flooding potential. So it's 6 to 1 sometimes. So when we're looking at this, but see, you can see Yuma's been like, hey, I got some. Mojave County, great. We're looking here at Pima and Pinal, dry a little bit right in through there. You're looking at Cochise over there. You're looking at Greenlee and Graham, not so much. There's Maricopa right in the middle. So it's been fairly dry for the monsoon season. When we're looking at these kinds of things, like, is this normal? And I compare these. I mean, that's what I do. I sit there and I'm like, okay, let's compare these to this and this to this and see where we're standing. And so how was last monsoon season? Do you remember it? Yeah, it was worse. It was worse, right? So then I go, okay, thank you for what water we did receive. Thank you. It could have been better, but we got more than we got last year. And it's, kind of looking at these kinds of things. 2021, 2022, really great monsoon seasons. That's actually when I started as the Arizona State climatologist, was in 2021. And I'm like, hey, I can take this. This is awesome. 21, 22, and then the last 3 monsoon seasons have been dry. Is that normal? Yes. It absolutely is. If you look at what's been going on for the last 10 years or so, it kind of goes to wet monsoon to dry monsoon to wet monsoon to dry monsoon. So the most we've had in order, in line, where we've had dry monsoon seasons, 5. So can it happen again? Yes. So is it going to happen? Please don't let it, right? But, when we're looking at these kinds of things, it popped up. Understanding how that monsoon operates is important. So we're looking at, those H's and then the L's. We want that H to kind of set up over the Four Corners region, right? So you may have heard about that, the monsoon ridge. And you're like, but you just said the ridge is bad. No, when we get it set up in just the correct location, it can bring that moisture coming in from Mexico. So having that orientation and that setup, holy cow, we pay attention to quite a bit. And so it looked like we might have things setting up correctly-ish for the monsoon season. And it happened a couple of times, and we were kind of excited. And we did have some tropical system moisture coming in June. We're like, okay, let's do it. And it just never, it kind of fickled off. But one of the things that we pay attention to now is, okay, monsoon, let's just forget about it, right? And what happens next? Winter precipitation. And so paying attention to what happens with that winter precipitation. One of the aspects that we need to pay attention to in my neck of the woods is understanding what the soil conditions are like. Well, you have to pay attention to soil conditions as well. For my purpose, I want to understand what the soil conditions are doing from the summer through the fall, because that will affect when we get our snowpack in the winter. So when we get that snow kind of in the upper elevation, so the Verde Basin, the Little Colorado Basin, the Salt Basin, looking at where that snowpack is going to happen, that's what we pay attention to understand where's that melt going to go, right? So when you have a wetter monsoon season, that doesn't necessarily impact our water supply, right? But it impacts what happens with our ecosystem. It impacts what happens with our soil. And if our soil is wet, and here we're setting up for winter and we have snow, and that snow melts, that water is going to, instead of going into the dry ground, it's going to be like, hey, I'm going to run off and move into your water supply. And so we look at that, and that's called that efficiency for runoff. If we have dry or wet, it affects what happens with that snowpack. Here's a term for you when we pay attention to our snow, and this is stuff that I measure all winter, is snow water equivalent. We just call it SWE because we think we're cool when we call it SWE. So it's snow water equivalent. And so we're measuring the snowpack, but then when you're dealing with snow, here's some fun stuff, is when you're dealing with 10 inches of snow, if you were to melt it down into water, it's usually a 10-to-1 ratio. So usually about 10 inches of snow melts down into 1 inch of liquid precipitation. So that's what we're paying attention to, snow water equivalent, the SWE. How much water are we actually getting? Last winter, not so good. We were dry in Arizona. So December, we're like, where's the snow? January, where's the snow? February, we got a little. March, we got a little. In fact, March was when we had most of the snowpack for those basins. And then a little bit, we actually got some snow in April. But by then, it's too late to get significant amounts. And so that's what we experienced for our winter precipitation in Arizona, unfortunately. And then this comes. So one of the other things that I pay attention to is the water year. I don't know, do you folks is that terminology something that you pay attention to? I'm not seeing I know, the water year, whatever. What is that? The water year is how, it's kind of like the calendar that we use to count our water supply, not just in Arizona, the United States and Canada. We have what's called a water year, and it runs from October 1st and it ends September 30th. So not only are we ending the monsoon season, we're also ending the water year for Arizona and New Mexico and everybody else. And that's how we kind of pay attention to it. The reason why it's set up that way, because we start in October, and that's kind of getting us into the surplus snowpack, where we're getting that surplus coming in. And then it ends with the summer where you're melting everything and getting that runoff. So that's kind of how it's set up. It's based on that. So the water year. So the water year's about to end. We've had 11 months of that water year, and we call it, this is water year 2025. So we end it when it ends. You know, that's the water year that we're dealing with. And we do this at the state level to kind of keep track of what's been going on with our water supply and our drought. And when we're looking at this stuff, so I pulled in the Southwest numbers right in through there. But you can see I pulled in, these are rain gauges in Arizona and in New Mexico. And we keep track of like, okay, so let's look at that precipitation that's been received at that rain gauge since October, and how does that compare to other years? So you can kind of say, has it been drier or has it been wetter? And when you're looking at these numbers that are in brown over there on our maps, those are rankings. Like, is this the driest October to August on record compared to other years? And unfortunately, that's what we're seeing. A lot of the gauges, especially in Arizona, southern Arizona, you can pop over into, we don't have too many, you've got some over here in New Mexico that you're seeing those same kinds of numbers. It's been very, very dry for the water year. I pulled in, so the statewide for Arizona, but I also pulled in New Mexico over there. Now, New Mexico seems okay, right? If you add everything together, I mean, the eastern part of New Mexico has been going, hey, I got plenty. And it got it because when we're looking at the monsoon season, that's where it mostly operated. It got started in June, it operated, it's kind of tapered off in August, but there was enough precipitation to keep everything going. So you're seeing the greens over there on the east side of New Mexico, but over here by us, at the border, you're definitely seeing that there was that same deficit of precipitation. So Arizona, and then also keeping track of those numbers. Like I've said, if we look at a year's amount of precipitation statewide, so I deal with a lot of zooming in and zooming out. So let's zoom out to the state and look at that precipitation for the water year. The long-term average, so if I go back to 1795, the long-term average of precipitation, annual precipitation for Arizona's that 12 inches. But if we look at what we've been dealing with our drought right now, we're about an inch below, about 11 inches. And so then kind of comparing all that, so you're looking at this kind of stuff. There's that long-term. Here's where we rank. That's Southwest. But for Arizona, we're ranking the second driest because we've been dry. The Southwest, if you pull in Colorado and New Mexico on the east side, it makes it look a little better, but it's still very, very, very dry. Very dry. Right. That was fun, wasn't it? Yeah, I know, right? These are the numbers. And so when I start looking at these things and I'm like, oh, this was the second driest. What was the first driest? And you look at that kind of stuff. And so when we're looking at where we're going back, like the 2000s and those kinds of numbers, it's been fairly dry. Now, this kind of stuff. Now, our office does not make these maps. I don't think I put in any of my maps that I talk about, but I'll talk about the next long-term drought kinds of things that we do. But we pay attention to what goes on with our short-term drought maps. And you can see these kinds of maps. I tried to pull in, so Arizona, New Mexico. So we've got the four corners still right in through there. And then looking at all of the West. And I wanted to kind of say, well, what was it like in 2023? What was it like in 2024? Same time frames, right? And then where are we at right now? So that's what you're looking at here. And you can see that last year, 2023 for Arizona, our winter 2023, exceptionally wet. We were happy. It was great. We had water that was being released along our systems and going all the way down from Phoenix down to Yuma. I mean, that was an exceptionally wet winter in 2023, very wet. And then we dried out. And you can see that drying out from a wet winter, what that can do with our short-term drought map. The oranges that you're looking at, those are more of the angry colors. But over here, you've got some of the tans and the yellows. The yellow just means abnormally dry. That's what that means. You can see places that didn't even have any of our short-term drought. And then you pop into 2024. 2024, the winter of 2024 for Arizona, it was okay. It was wet-ish. It wasn't really wet, but it didn't go into our dry category, so it was wet-ish. So we had a wet winter 2024, and then we dried out. So we had a dry monsoon, and you can kind of see how that plays a role. And you see where it landed. So it was on the west side of Arizona through central, and there's Cochise County, the southeast, really dealing with some persistent kinds of lack of precipitation. And so that's where we're at over here. So when you're looking at Arizona and New Mexico, we've got now those numbers and those colors that are showing us that we're dealing with severe short-term drought, extreme short-term drought. So the extreme is in the red over there. And then the exceptional short-term drought, those are in those darker reds over there, and that's going right up along our line. That's where we're at. Does that kind of match what you've been experiencing? Now, precipitation yesterday doesn't count necessarily. We're happy to have it, but when we're looking at kind of that longer term or that shorter term impact, we kind of have to look beyond that, just that one day. So there we're dealing with that. Last 12 months, yeah, we look at these numbers too. These numbers are looking at, Arizona, the third hottest. You can see the Southwest, the fifth hottest. And you're looking here at precipitation, even the last 12 months. So when looking at the last 12 months, it's the second driest for Arizona. So then we look at, so this is September to August. So I'm just looking at the last 12. What was the last 12 months looking like? So September to August, last 12 months. Number two for Arizona. What was number one? It was 2001 to 2002. So still, but you're seeing it all over, right? So it's not just Arizona. It's not just New Mexico. It's the Southwest dealing with these kinds of situations. And then just for fun, so we looked at a year, right? What has it been doing? Let's look at 5 years of data. Do I do that? Oh my gosh, yes I do. Who loves this? I mean, you have to love this to do this. And I love what I do. I love being able to kind of look at these things, see where we're at, provide that context. Where do we stand? How do things land right in through here? So looking at our long-term deficits. Up here, so it says, see up there, it says SPEI, this map that has all of the angry colors on it, right? The SPEI is the Standardized Precipitation and Evapotranspiration Index. Evapotranspiration, I teach that to all my intro geography students. Everybody needs to learn evapotranspiration. It's the combined loss in vapor form from plants and land surfaces, so evapotranspiration. And what this map can help us understand is it can look at the precipitation and how dry we might be, but it also takes into account temperatures. And with hotter temperatures, you have a thirstier atmosphere. So a hotter temperature means that you're sucking that moisture out of the ground. So we pay attention to that when we're looking at our long-term drought map for Arizona. We look at these kinds of numbers. Does that make sense? Yeah, it seems about right. So back to Arizona and how long we've been in drought. Here's the weird thing when we're looking at these kinds of situations, and I'll go to the next slide and you can see kind of where we're standing. When we're looking at, are we in drought? The first time Arizona identified and put out a situation statewide that we were having drought issues, that was 1999. I look now and go back to when did that drought actually start? 1994. Was anybody here January 1993? Anyone? Any January? Yeah. January 1993 was the wettest January on record for the state of Arizona. Everywhere. Lots of water. And then after that, you go to 1994, boom, that's when our drought began. And it's not every year, right? So it's not that you have every year is a dry year. It's that overall, looking at what we're dealing with, we have wet seasons sometimes dry seasons, but overall, if we're looking at the last 30 years, about 20 of those seasons are going to be dry, and maybe 10 will be wet. But again, not every time. And so that keeps us in this long-term drought. So what we can expect for kind of the next through winter into maybe into December is that we're going to be expecting that that seasonal long-term drought to kind of continue to persist. Maybe down here where we are right now, it might slightly improve. Maybe. We'll have to take a look and see. Hopefully we can. So these are just outlooks. Now, here's the other thing. This is not a forecast saying it's absolutely going to happen. But given what we've been dealing with and what we see and potentially what's going to happen in the fall, potentially we might have some improvement. And with yesterday's precipitation, I mean, great. That's excellent. That's part of it. That's part of helping things improve. So we look at stuff like this. And so we're looking at maybe what we expect to have happen this month. So this is kind of what we've been experiencing. Equal chances of precipitation over there, maybe not as hot. And it's kind of been ish like that, right? So it hasn't been as hot. I mean, I'm looking at last September's numbers for Arizona. That was the hottest September on record last September. So, and then we hit 117 degrees in Phoenix in September last year this time. So we're not probably, fingers crossed, don't quote me, hopefully not get that in Phoenix this September. But it's been a little bit cooler, right? Has it been? I don't know. What do you think? And yeah, I know, right? Right. So hopefully we'll see. We'll see what we're experiencing. We'll look at those numbers. I mean, Phoenix is still hot. Places in Arizona still very warm in September. I'm not expecting us to go below average in September. And I'm not expecting us necessarily, but we might. Because we look at stuff like, there's the potential for the next 8 days, the end of the month into November, that there might be some of the cold front kind of winter storms might be wanting to come into Arizona. We'll have to wait and see. So these are outlooks. These are kind of like, hey, we're getting an idea that this might happen. Not 100% sure, but absolutely. And then we look at what may happen September, October, November. I start paying attention to what's going to happen with winter precipitation. I already have started looking at that and kind of that potential to get precipitation or not. And you can see over there with the seasonal outlook, I mean, it's expecting us to be warm, but over there is seasonal outlook expecting us to be dry. And one of the bigger things that controls our winter precipitation is El Nino, La Nina. Are you guys familiar with that? Yeah, so for the super cool way of saying it, you can combine those and say ENSO, which is the El Nino Southern Oscillation. But then we have those two phases. We have the El Nino, we have the La Nina. And this is based on the sea surface temperatures in a very specific location, the equatorial Pacific. So then you have to look at maps like, have you ever seen a map like this? This is awesome. So you're looking at the basin, the Pacific basin. So in the middle there is the equator in the Pacific Ocean. And so you can kind of see Australia over there, and you've got Central America and South America over there. Yeah, that's what these are. So looking at the temperatures at the sea surface temperatures. And then we look at is it hotter or colder than normal? We call that an anomaly. And so with the La Nina, we tend to have a lot of those blue colors showing up in the equatorial Pacific. It's colder. And what that means is, statistically for Arizona, the storms won't come into Arizona in the winter. That's what we want. We want to have them come into the winter in Arizona. We want to have them come in. But with La Nina, statistically, we tend not to be able to get that storm track coming into Arizona. Does that happen every time? No. Sometimes we have a La Nina that's really, really wet. So it's a statistical kind of thing that we understand. But for the most part, when we're looking at what we're experiencing here for Arizona, there's a 71% chance that La Nina will develop. And again, statistically, that means Arizona tends not to get as many storms. And so what that means is we have a 33 to 50% chance of having a drier winter. So that's kind of a little bit, which is what I have to say to all of y'all. But I am happy to answer questions. I think I have 5 minutes. If you have a question, yes, what's the question?